I'm going to go over mock test question number 1. And this time I'm going to try not to mess up the equations. Okay, so black elk leaves the board. He goes up, he goes down. It's a 10-meter board, which means that to the water it's 10 meters down, right? His initial velocity is 5.8 meters per second, which means he's going up, right? And the first question is, what velocity did he strike the water? What time did it take him to reach the water? We can do that from here to here in one fell swoop. Right, so the displacement is down 10. Yeah, just tuck it into your arm like a football.
Okay, and then
the initial is...
I lost mine.
Huh?
How far through?
How far through? They're in the hanging file there in front of G. And then the acceleration is negative 9.8. Yeah, this is the first one, right? And then basically we want to find this one and this one.
I should go up here and do the mock test.
And I'll put the solutions online, so you ought to be able to just look at them if you want. Okay. Huh? Can you sell pretzels? Yes.
Okay, does anyone want $2 pretzels?
$2 pretzels.
There's only 2 left, so.
2 left. $2 pretzels. $2. Anybody want $2 pretzels? Okay, $1 pretzels. No, I'm just kidding. What?
No one?
I'll take one for free.
For free.
What is it?
It's tempting, but no. Okay.
Original.
So VF squared is VI squared. This is what I'm going to do. I'm going to use this guy to solve for this because I don't have t, right? So VF is equal to the square root of 5.8 squared plus 2 times negative 9.8 times negative 10. Yeah? Let me film this and then I'll answer your question. Okay, so 5.8 squared plus 2 times 9.8 times 10. I'm too lazy to put in 2 minuses. Okay, so this one is the final velocity. The absolute value is 15.1538, right? But you know when it hits the water, he's got to be going down. That's why it says negative 15.2 meters per second, right? And then to find the time, you're going to go, I'm going to use VF as VI plus AT, right? So 15, and I'm using the unrounded, 15.15 is equal to 5.8 plus negative 9.8 times t. We don't know t, right? So solve that. 5.8 divided by 9.8, 2.138. Right, so time in the air, 2.1 seconds. Velocity hits the water, 15.2. Did you guys get, nobody's paying attention. Did you put the minus on there? That's important, right? So he's going down 15.2, 2.13. And then the final thing is, to what height did he rise before going down? So for that one, we're going to go from here to here. And of course, at the top, the velocity is 0, right? So x, vi, vf, a, and t. At the top, the final velocity is? 0. It's 0, 5.8, negative 9.8, right? And then x, I'm going to use the same thing. I'm going to use this guy. So vf squared is vi squared plus 2ax. It's like a very handy formula, right? So 0 squared is 5.8 squared plus 2 times negative 9.8. And x is what we're solving for. You're going to draw a little separator. So that's going to be 5.8 squared divided by 2 divided by 9.8. 1.716 meters. Right, so that is how high. So our answers are velocity is striking the water down 15.2, and you got to just put the minus sign on there. What time to hit the water is meters, that's seconds. Very good. right? To what height did he rise before going down? 1.716. And then the graphs are, if we do position, right, he's going to go, we start here, we go up to 1.716, right? And we go down to 10, right? So he's going to go, right, hitting the water at minus 10, right? And then if we do velocity time, we've got positive 5.8, and the final velocity is negative 15.2. Here's 0, right? So when he hits the water, he's here. When he leaves the diving board, he's here. When he's at the top, he's here. And then this should just be a nice straight line, right? So there he is there, hitting the top, hitting the water. It's like a shake weight.
Did it break?
Uh-oh.